now that we've performed various types of installations, we want to show you how to set up an automated installation or Kickstart base configuration, which will automate or allow you to perform a hands-free or semi or majority hands-free installation. So thus far we've installed using custom partitions or implementing custom partitions, as well as implementing RAID 5 and logical volume management. So now let's label this section Kickstart Configurator, and we'll approach Kickstart automation in two parts by first focusing on the GUI application provided with Red Hat Enterprise Linux, and then by actually implementing the automated installation as another installation that we perform. So what are some of the features provided by Kickstart? Well, the main feature is that it provides hands-free automated installation, which means the answers to the questions are provided via a script. So it's a scripted installation. Scripted installation. Script can be used on multiple systems to quickly deploy those multiple systems. As we've mentioned multiple times, with each installation of Red Hat Enterprise Linux, a Kickstart configuration file named anaconda-ks.cfg is created, and that file contains the answers to the questions presented during installation. However, you may see comments in the file when you use more advanced partitioning schemes such as LVM. The utility that you need to run in order to make use of the Kickstart configurator is system config Kickstart. This utility isn't installed by default. Let's just note that. System config Kickstart is not installed by default, which means you'll need to use add-remove programs in order to, or add-remove software in order to install it, or install using RPM, the RPM directly, and it will mention the Python dependency that you can fulfill. So there are two RPMs that need to be installed: a PyKickstart RPM first, which Kickstart depends upon, and then the main Kickstart RPM, which is system-config-kickstart, the version.rpm. We've gone ahead and installed it, and we can confirm it by executing RPM query all grep case insensitive for system-config-kickstart. So this is the version that's installed currently. And to execute it from the shell, simply execute system-config, and if you use tab completion, you'll see the various system-config utilities that are available. However, we're interested in Kickstart. This will pop up the GUI, which provides a blank template for us to manipulate the configuration or the script that will be created. So here is the Kickstart configurator. Unless you open a file directly, it provides us with a blank template, a sheet that we can use to control or influence every section of installation. There's a basic configuration section. Here you specify the default language used during installation, the keyboard type, time zone, whether or not your clock uses UTC, and if you've recalled from our multiple installations, these are the questions that are asked during installation, so we have the ability here to influence the answers. A password for the root user that will be assigned to the user root once the system's up and running. Whether or not to encrypt root password, this should be default, and it is selected by default. The target architecture, these are the architectures supported by Red Hat Enterprise Linux. Whether or not the system should be rebooted after installation, whether or not the installation should take place in text mode, or if it should be performed in interactive mode, which means that although we will provide the configuration with a script, it will still prompt us for answers and to confirm the answers. Beneath the installation method, or within the installation method option, you'll see whether or not the installer should perform a new installation versus upgrading, and the different installation sources, including local as well as network-based media. Bootloader options. whether or not grub should be installed, whether or not a password should be assigned, and where grub should be installed, whether in the MBR or on the first sector of the boot partition, and any additional parameters that should be passed to the kernel to support your system. Again, these are all options that we see during installation. The ever-important partition information. To effect a fully automated Kickstart installation, you must define partitions. Ideally, you should define simple partitions. However, as you can see, RAID is supported, but you need to have RAID devices before you can create, or RAID software partitions before you can create a RAID device. So in the partition area, you can create, currently with Kickstart, basic partitions as well as RAID-based partitions. Network configuration. Which device to automatically assign? ETH0. Should it be DHCP or static, or use the BootP protocol? If static, then you'll need to complete IPNet mask, gateway, and primary name server. Authentication, whether or not your system authenticates against NIS, LDAP, Kerberos 5, Hesiod, Samba, or just use the name switch cache daemon. So these are options for authentication, but the default uses shadow passwords and encrypts the contents of the shadow password file using MD5. Firewall configuration. The default is to enable it, permitting SSH access to the box. You may optionally indicate additional ports. Whether or not SE Linux is active, disabled, or provides warnings. Display configuration. What resolution to set the display at, what color depth, whether or not the video card is automatically probed, and these are the different drivers supported. If you don't select probe, you see a list of drivers supported. The dimensions of the monitor can be specified, otherwise the kernel will probe, the installer will probe. Whether or not to start X Windows on boot, meaning whether or not to enable run level 5 versus run level 3. When checked, run level 5 will be the default run level indicated in ETC init tab. When deselected, run level 3 will be the default. Whether or not the setup agent is launched upon first boot. It's disabled by default in the template, but can be enabled or enabled if you're reconfiguring the system. There is a way or mode to reconfigure your system for different purposes, all without reinstalling the system. Package selection. This option currently doesn't exist. Pre-installation and post-installation scripts. You can define scripts that are to execute before and after the installation for various purposes. So again, the Kickstart configurator controls every aspect of installation from beginning to end. Once you've created the file, you should place it on an accessible location such as an HTTP server. Optionally, you can place it on the boot CD-ROM, but that takes a little more work, such as burning the ISO Linux subdirectory, including the Kickstart configuration file. So you can specify your Kickstart configuration file on a centrally accessible repository such as an HTTP server, and you can locate multiple Kickstart files there and indicate or direct your systems administrators and or users to reference the appropriate Kickstart configuration file. Now, without further ado, let's open the Anaconda Kickstart configuration file that currently exists on our system. This is a copy of the Kickstart file that was created as a result of our recent installation. The partition information will be commented out. There will be no partitions defined because we elected to set up an LVM-based partitioning scheme, which isn't supported by Kickstart. RAID is, and had we defined RAID partitions, then we'd have the ability to define or to interact with the RAID partitions that were defined, which explains why the LVM section of the anaconda-ks.cfg file was commented out. However, beginning with basic configuration, the first menu item, you can see that some defaults are indicated, such as not to use the UTC clock, the default time zone, a password for the root user, which is encrypted, the fact that the system should not be rebooted, the installation should not take place in text mode, and the installation should not take place in interactive mode, meaning it should be fully automated. Again, this is a certification objective, the ability to install your Red Hat Enterprise system without intervention. So once you've set it up manually the first time, providing your disk partitions are laid out and interpreted by Kickstart properly, you should be able to set up a server without intervening. So basic configuration looks clean. Let's move on to installation method. Notice that HTTP is selected, a new installation will be performed as opposed to an upgrade, and the HTTP server and directory is already specified. Always indicate the directory that contains the server or client directory. So don't indicate /server, for example. Just indicate the top-level container for the server directory in the case of installing Red Hat Enterprise Linux, which will cause the installer to find the server subdirectory beneath, in this case, RH5i386. Bootloader options. A new bootloader will be installed, but currently no grub password is set. So let's go ahead and set one to further increase the security of the system, and of course we'll elect to encrypt that grub password. The grub or Grand Unified Bootloader will be installed in the master boot record, and here are some kernel parameters that are passed in by default: RHGB and quiet. Let's move on to partition information. No partitions are defined by default because we elected to set up the system recently using LVM, which is currently unsupported by Kickstart. However, the master boot record will be cleared. All Linux, or all partitions that is, including Linux partitions, will be removed. The disk label will be initialized. So at this stage we need to define our partitioning scheme, and we'll do so without RAID or LVM. Again, LVM is unsupported, RAID is supported. If we wanted to add RAID, we'd simply define software RAID partitions and then create a RAID device beginning with MD0 and then assign a mount point to that RAID device. But to keep our installation simple, let's click on Add and define the layout of the partition. It's always a good idea to begin with the boot partition as it houses the Linux kernel. So our boot partition, which will be of size 100 megabytes, will be defined on a specific hard drive. This is a neat feature of Kickstart. If you know that your system or systems that will make use of this Kickstart file has multiple hard drives, specify the hard drive that the partition should exist on. Otherwise, the installer will default to the first hard drive. So we want this partition to be created on SDA, or the first hard drive, the first SCSI hard drive that is on the system. We want the partition to be formatted, and we'll click OK. So now we've got a partition on SDA for boot. Let's also create a root partition. So that's simply /, or you may use the drop box and pick /, and we'll set its size to be 10 gigabytes. This will leave us more than enough space for doing other things later on, such as creating additional partitions. It too will be on drive SDA. So now we've got two partitions, boot, root. Perhaps we should also create a var partition. So we'll add from the Dropbox var, and we'll make var 10 gigabytes as well. And we'll create it on drive SDA. So we've now got boot, root, and var. Now we should create a swap partition. Let's do so on the second hard drive. We'll add, and the type will be swap, which will null or void the first option, and its size will be twice random access memory, which is the suggested size for creating swap partitions, as well as swap files. We can indicate a disk or an existing partition. We'll make a partition on a specific drive, SDB, as opposed to SDA, and the partition will be formatted. So now in SDB, we would have created a partition, and here it's set to, let's modify that, it should not be RAID, this should be swap. We inadvertently selected RAID, so that's swap as opposed to RAID, but we could create a RAID device with Kickstart. So far we have in place boot, root, and var. These are three primary partitions. If we create additional partitions on the first hard drive, an extended partition will be created to house n number of logical partitions. Otherwise, these three partitions will be the only partitions on the first hard drive. But these are enough partitions to move forward with our Kickstart installation. So with that said, let's move forward. We'll save Click on Save File. This will save, and we'll save it as, instead of anaconda-ks.cfg, simply ks.cfg, and then move on to network configuration. ETH0 is already indicated for us because the installation was set up to assign DHCP to ETH0, so the settings were preserved. If you edit the network device, you'll see the ability to switch from DHCP to static or static IP or BootP. If DHCP suffices, let it be and move on. Authentication will use shadow passwords and MD5. None of the other name services will be used for this particular installation, but they are supported. Firewall configuration, it will be enabled and SSH will be permitted. The trusted device is the lone network interface on the server, ETH0. SE Linux will be active. Display configuration, color depth 8 bits or 256 colors, 640 by 480. However, once the graphics card is properly and monitor are properly probed, the resolution will switch or shift to 800 by 600. The setup agent will be disabled on the first boot up, but we can enable it if we like by simply dropping the box and changing it to enabled. The X Windows system will be configured. The video card will be auto-probed. Ditto for the monitor. Package selection isn't indicated. However, the Kickstart file has a list of packages that we selected during the manual installation of the system, so those packages will be reinstalled. Now, with that said, we have a fully functional Kickstart file. Let's save the file. We need to publish this file to the HTTP server as it is accessible, and then we'll be able to make use of it. So let's just note steps. Open previously created anaconda-ks.cfg file and modify. Define partitions appropriately or accordingly. Confirm settings. And last but not least, publish the anaconda-ks.cfg file to HTTP server. Now we're going to upload it to the server as simply ks.cfg, which we resaved it as, so we'll just indicate this as ks.cfg. So that said, let's copy the file to the server. And we'll save it. That's fine. We'll overwrite whatever changes were made. We'll clear screen and then SFTP to, as the user root, the server which functions as the repository, the .100 box. Prompts us for authentication. We'll navigate to the web root, which is beneath serve, www.linuxcbt.com. We'll then input ks.cfg, and it's been uploaded. With that said, we should confirm that the settings are there, the file and the appropriate settings are in the file before we begin the installation process by logging into the remote system, obtaining a full shell, navigating to serve, www.linuxcbt.com, and executing a less of ks.cfg. And we'll just peruse the settings. Uses shadow password for authentication. It enables MD5. The bootloader will append RHGB and quiet. You can consult the Linux kernel to see what RHGB and quiet will do. Location, MBR, that's where grub will be placed. MD5 password to manipulate grub is represented by the following string. The drive order includes A, then B, then C. The master boot record will be cleared. All partitions will be cleared, and the device or the disks will be initialized. The installation will be graphical. All the lines with hash marks, beginning with hash marks, are comments, by the way. The firewall will be enabled, permitting SSH access. The first boot registration screen will be disabled. The key, or the insertion of the key, will be disabled or skipped. The US keyboard and languages are set. Logging level is set to info. The URL to obtain the binary files for this release of Red Hat is indicated, followed by its path leading to the top-level container of the server directory. The boot protocol is DHCP. The device is ETH0. Whenever the system boots, the interface will be brought up. Root's password is encrypted as follows, using MD5 as the encryption algorithm. So instead of representing the password in clear ASCII text, it's represented using MD5 or MD5 encryption, that is. SE Linux is set to enforcing, the time zone is set. The OS will be installed as opposed to upgraded. Xconfig, the utility used to configure the X environment, will be run, setting a default depth and resolution. X will be started on boot, which means the system, providing the X configuration works flawlessly during this Kickstart run, will cause the init tab file in etc to be set to 5, to run level 5. And just to point out where that file is, in our local system, if we do a less of etc init tab, there's an entry for init default. The second column after ID indicates the run level that is the default for the system. So ID followed by 5, indicating that the run level default for this system is 5. If X is unsuccessfully configured, run level 3 becomes a default. And then we move on to the main area, which includes disk partitioning information. /boot root var and swap will be created with attributes per mount point and partition. Bytes per inode, the file system type, on which disk they should be created, and their sizes. So all of that's spelled out in the Kickstart configuration file. Then below that we've got a list of package groups. %packages followed by names of groups prefixed with the @ symbol indicate the categories of those package groups. Office, editors, core, so on and so forth. And here's some extras, including system-config-kickstart. If you recall, during the installation, we navigated to the advanced tools, or to the administration tools, that is, and selected system-config-kickstart, which rendered the way you see it here in the anaconda-ks.cfg file. Now again, with Kickstart configuration, you can define pre- and post-scripts in the event that you need to communicate information or messages related to installation before and after, such as installation has begun in a pre-script, installation has successfully or unsuccessfully completed in a postscript. So this file is there, and we'll be able to access it. Now, let's just note that when we reboot the system, so the 5th step, install server, using the following at the main menu. Linux space to tell the installer that would like to pass options in, ks equals, and the full path to the Kickstart configuration file, which is http 192.168.75.100/ks.cfg. We haven't placed the file beneath RH5i386, so we've placed it right off the root of right off the web root, that is. So we need to specify this. Now we should also note the following can be used to boot a Kickstart installation. 1. boot.iso CD-ROM. So from the images subdirectory, if you create, and that's the images subdirectory of your installation source. So let's take a look here just to show you our 5386. And in images, if you create a CD-ROM based on the boot.iso file, which is only 7.2, 7.3 megabytes, you can boot with this CD-ROM or the CD-ROM created from this boot.iso. And then at the main menu, indicate Linux space ks equals and the path to your Kickstart configuration file. You may also boot with the first CD-ROM of the RH5 installation set, which should be about 5 CDs. You may also boot with the DVD-ROM of the RH5 installation set, and you may also boot with a USB pen. And the USB pen or a USB stick can be created using the diskboot.image file, which is beneath the images subdirectory. So this you create using diskboot.image, and you'll use the dd command using referencing the diskboot.image file as the input file, and the USB device location as the output file, which will cause the USB pen to be written in such a way that if your BIOS supports booting from a USB pen or USB stick, then it'll boot from it. So these are some of the ways you can start a Kickstart installation. You have multiple choices available to you. Now with that said, we need to reboot the server that we recently installed. This is the Dell server, not the VMware instance. We'll use the boot ISO CD and then reference the Kickstart file and then watch the installation take place without our intervention. Once it's completed, then we know we would have covered, or we can then claim we know how to implement a Kickstart-based installation, which again is a certification objective. It's really straightforward. So long as you take care of the main areas plus the partitioning information, you should have very little trouble whatsoever. And even if you're prompted during installation or automated installation, you should be prompted for very little information. So with that said, let's move on to the installation in an automated fashion. So now we're rebooting our system after the previous installation, and we should be up to the main menu momentarily. Again, we're using the boot ISO created CD-ROM, which is about 7.3 megabytes. So it has very little, and it relies solely on the network. And we've already published that ks.cfg file, the Kickstart file, to our HTTP Apache server, so that it's centrally accessible. Again, in your environment, if you intend to set up many systems this way, then publish multiple Kickstart configuration files. They don't need to be named ks.cfg, just name them whatever makes sense, such as department-ks.cfg. And now we're at the main menu, so we'll go ahead and indicate as mentioned Linux, and that's going to be Linux space ks equals, and the full URI, HTTP, the IP address of the server, followed by the path to the file ks.cfg. Again, you don't need to name the file ks.cfg. The installer will take any name you supply, and if you're installing multiple systems, such as classes of systems, perhaps grouped by department or purpose or intent, then simply name those files or organize those files into distinct directories and distribute those files to the appropriate administrators setting up the servers. So let's go ahead. Linux ks equals, and if you wanted to turn this into a text-based installation at this point, you certainly could. Append as many options as you need. The ks option is the key option. Now again, the Kickstart file can be placed on local media, such as on a CD-ROM. But for our intents and purposes, the ideal place to store the file is on a network location, such as an HTTP server. Makes it easy for us to update. We don't have to burn CD-ROM, so on and so forth. So let's continue. And now we're propelled into the main interface, and this is going to go by relatively quickly. The key drivers are being loaded. Request for an IP is being sent, didn't prompt us. Stage 2 image is being downloaded, meaning the network is working. And momentarily we'll be in graphical mode. Probe is taking place. Installation information is being retrieved. Again, this is all without my intervention. So this is all premised. The installation, that is, the automated hands-free installation, is premised on having successfully installed the server once and simply modifying the original anaconda-ks.cfg file such that it defines partitions using either RAID or standard Linux partitions. In other words, non-LVM based partitions. Perhaps in a later release, LVM with Kickstart will work, but in this case it doesn't. So be prepared to perform Kickstart with RAID or optionally non-RAID partitions or non-RAID, non-LVM partitions, meaning standard Linux partitions. Dependencies are being checked for the selected packages, which tells us that we're at that stage of installation where the installer has moved to the location of the file where the packages are to be specified. And also, the installer has to ensure that the packages are available on the server, on the HTTP server, or on the network-based server. Now, there are other network types supported. As you know, FTP and FS are two other types that you can use to install your Red Hat Enterprise server. HTTP is just one easy way to get it done. So we'll just wait this through, and once the files are, or we're at the stage where the installer has begun copying files, then we'll elapse the installation so that it doesn't take us as much time. We're wrapping up here the dependencies. Again, for the packages selected, the installer needs to be sure that all dependencies have been met. Otherwise, you'll end up with broken packages or software that doesn't launch correctly or components of software that don't work correctly. We've been propelled into the formatting of the file systems, which includes root, boot, and any other file systems that we've defined. var, as you can see, swap is another file system we defined. And again, with the exception of specifying the KS option at the main menu, we have not intervened with the installation. So this is truly a hands-free installation. And so long as you can keep your partitions generic enough to meet the classes of systems that you have, you should have no trouble whatsoever setting up systems automatically. The two concerns are generally network configuration and disk partitioning when considering deploying an automatic installation to multiple systems. However, you may also be concerned about software, but if you need to get many systems out in a hurry, this is the way to do it. Certainly, you could always consider Ghost, or a software like Ghost that does drive imaging. However, if you want to remain within the framework provided with the Red Hat Enterprise software, then this is how you use it, the Kickstart. Now, as you can see, we've already begun the process of file copies. So it's just a matter of waiting, and the release notes are available. We can interact with it. The interface is totally available, and the various consoles, the Control-Alt accessible consoles are available that we can interact with to learn about the installation as it takes place. So this is working successfully, and we will check back in as the installation nears the end, just to elapse it in the interest of saving time. And at this point, we're nearing the halfway mark. We have approximately 8 minutes remaining. So far, so good. All the files have been copied. Now, if during a Kickstart-based installation, especially across the wire, you see errors regarding the copying of files, just click on retry. Sometimes that comes up. It hasn't in this case, but sometimes it does, perhaps because of network congestion, or if from a local media, perhaps because the media is dirty. So if you do encounter that, as I've seen on multiple occasions, then just click on retry, perhaps eject the media if you're using CD or DVD, clean it, or check the connectivity to your network-based server, HTTP, FTP, NFS, etc. We're just over the halfway mark with roughly 6 minutes to go. And here's an example of the inability to copy an RPM, cool key version RPM. So we'll click on retry. Sometimes this pops up, especially when there's network congestion. So just click on retry, and the pop-up usually goes away. And we're getting down to the wire here. Just under 2 minutes to go. All the files have been copied and post-installation configuration is taking place, which includes setting up the grub environment. And momentarily you'll be prompted to reboot the system. If you recall, during the Kickstart configuration, we elected to not have the Kickstart automated installation reboot the system for us, so we have to reboot manually. And now we're rebooting, going through initialization as usual, and the system should be back up and running momentarily. So again, to recap, we've just performed a hands-free Kickstart installation. The only intervention necessary was in the beginning where we specified the location of the Kickstart configuration file. And everything else was handled by default by the installer. So now we're at the main menu. Let's ensure that the password's in place by attempting to modify the grub entry, and it doesn't let us, but P for password prompts us, and then it lets us. So this tells us that we've set things up properly. Now let's boot the system to full graphical user mode as opposed to single user mode as we've done thus far by pressing B to boot. Here the system's coming up, and we'll be in graphical mode momentarily. UDEV is starting, Universal Devices, and the different services will be brought. And now we're in graphical mode, 640 by 480. Spacebar to show details comes up in 640 by 480 with 8-bit colors. You can tell by the graininess of it all. Now, had we indicated 800 by 600 in the Kickstart utility, then the system would have come up in 800 by 600 mode. The installation was performed at 800 by 600, but X starts at whatever you specify in the configurator, the Kickstart configurator. So our system's up and running. We can log in and make use of it. So we'll log in as root. And we'll have a desktop at 640 by 480 momentarily. And there we have it. Let's just confirm from the shell the disk layout. And there you see boot var root, the partitions that we instructed at 10 gigabytes, with the exception of boot from the system configuration for Kickstart. So this is good. This is means we're up and running, and we can move on to other items.